Okay. I think that's all I want to say here. So I think I'm going to go into the uh, SSMS server, and we're going to create some indexes. So if you want to go in there, and we'll look at some of the performance information about a query, so you can get an idea of how the SQL Server uses those indexes to help sort or retrieve data. And again, because our data is so tiny, I don't think if you create anything like that, it will be even used in there. But at least you know that you'll see your index being created. It's in there. It's active, and so you can see it. I mean, it's too bad we cannot force it to use our index. I'm not sure how that's going to be done, but yeah, usually you don't get to choose it, so that's unfortunate. But I'll also show you that when you create an index, you can actually see the file size or the size of your database actually increase by 8K, because we talk about one extent is 64K, but each page is 8K. Okay, so until you max out that 8K, then it will jump to 16K and then 32K until 64K. Once you max out 64K, then it will create another extent and you start 8K again, right? So that's how they work. Okay, so in here, in the Unit 6, I just want to see some of the things that we created last time. You'll see that if I go into the tables in here, the courses table, okay, we have a key. We have the foreign key and primary key here. So the primary key is the index. Even though it doesn't say index, it is the index. It's a cluster index. It is only one cluster index per table. As you can see, you cannot create two indexes of the cluster type. You can see also another folder here called indexes. Okay, you see the indexes here. We have something called PK courses, which is exactly the same one. Okay, so when you create a primary key, that is the index key being created implicitly by the system. Okay. I'm not sure if employee has one. Let's see. Employee has it too. The phone number. If we have primary keys, then they all have it. Okay. Okay. So those are called clustered. If you expand this, you'll see that it says clustered. Okay. If it's clustered, then there's only one. You cannot create another cluster index in here. Here, the name here doesn't matter much. Okay, even though it says PK, it doesn't really matter because it's defaulted to that PK there. Now, usually indexes have the prefix of IX here for index. So I can see I changed that. I probably shouldn't do that, but so. And that's just the way it's named. Usually it has a PK for primary key, FK for foreign key, the IX for index, okay, the AK is the alternate key, which is a non-primary key, a unique key. Okay, so if you click on the database table here, do a right click, okay, and you go to the reports. Go to the standard reports here. It tells you about information about this database as well as the table. So if I click on disk usage by table, so by each of these tables, I have 4 tables here, it will tell me some information about that table. Okay. Let me see if I can do something here. Might be small, but we'll see. Okay, so you see that the table courses, employee, each of those have that many records. The reserved kilobytes. Remember that the database manages your size automatically, and it will always keep a certain percentage of your database record, just to make sure you have enough data to store. Okay, and you see that it has at the actual data size, the index, in kilobyte size as well. So the employees and the phone, they have no records, so it's all 0 in there. Okay, the student here has 8K of data, the 8K for that index as well. So we have the primary key in there. So each of those, as you can see, it has its own record, its own data. That's why it consumes some data there. If I go back and create a new table in there, so let's go over here, and I'm going to add a new query, and we'll use that unit 6DB. It's okay for now. I'm going to create a table. We'll call this what table do we have? Courses, employee phone, and then maybe grades. Call it grades. Right. So I'm going to create an grade ID of type, let's just say int, and I'm not going to make that a primary key. So you see there's no cluster index in there. We'll give it the actual grade, or maybe grade point of int. It's okay, and we'll have a var a letter grade of character just 1. So a very simple table, and I create that. So that's in there. If I go back to the disk usage here, I can still refresh here. If I refresh this, and I should see the new table created in here. So grades table, here it is. Has no record, no index, right? So 0, just like the other 2 tables here. Now if I go back to the Explorer here and check my tables under the grades, you see that there's no key and no indexes. Okay. So you can create an index for this table grades. And to do that, we're going to go back to the query here. Let me put that here so you can see my columns. I'm just going to go down here and create an index. You can do it in the command line. You can do it using the GUI interface. In the command line, you would do like create index we'll give it a name. So index usually takes the prefix of ix. This would be grades. Let's just say we'll take the column of grade ID. Okay. Grade. I could just put like grade ID maybe. Grades. Grade ID. Okay. On the table name is going to be grades. Okay, just make sure I got that that thing right. Right, so create. I didn't specify cluster or non-cluster or unique here. You can, right? Let's just say we create none without these two, and then we'll see which one it is. It should be non-unique and non-clustered. Yeah, so we'll see. Okay, so that grades table, and that you can specify the column. In this case, it's grade ID, and I want to have it ASC for ascending order. I mean, you don't have to specify that, but by default it will be. If you want to add another one, you can just add a column here. I mean, comma, and the next column, and then specify the sorting. Okay, so move that next line like this. Let's run this command. So complete it, and I can go back and check my grades table. Refresh that. Add a key. There's no key here. Index, and there's our index. Okay. Index is not unique and they're not clustered. So it's not the primary key. So that means I could have duplicate data. It's fine. Okay. So just to prove that, we can go and enter some data in here. Okay, so we can say insert into the table grades the values. The first one is the ID, which is a 1. The second is point, so we'll just say 90, and the letter is, we'll just say A. Okay. And I will go ahead and insert that. Should be in there. And if you want to see what's inside the database table, and this is by inserting data using the commands. You can also insert directly into the table visually. If you haven't tried it, you can do it this way. So go to your table right here, the grades, right click, and choose the edit top 200 rows, I think. And there you have your data there. So you can go ahead and insert directly into the table here. Okay, much quicker. So I can go to the next column, next row, and enter 1. Put like 85, and this is maybe a B. Right? So notice that I have duplicate in the grade ID. It doesn't matter because I did not specify, even though that is the index, is not unique, right? I didn't say unique, and it's not clustered. So I can have duplicate, it's fine. Okay, so now if I go back to my the information right here, this usage, notice that initially we had 0 because we didn't have anything for the grades right here, right? If I refresh it, you see that now grades has 2 records, and the data size is now 8K, and look at our index. For some reason it jumped to 24K. Yeah.
How did you get that? This
Oh, this one here?
Yeah.
You go to the database, right click, okay, go to the reports, standard reports, and you have access to all this information. The disk usage, I chose the use by table here. You can choose the top tables. It will give you a list of the top 10 tables. Well, I don't know how many tables, but the top tables. I'm not sure how many. So the table here, and that should give you this this screen here. You can refresh it every time. You can leave it here and refresh it when you add or delete data. It will tell you the status of the data size. Okay. Yeah, I'm gonna close this one. Okay, so we just added 2 data records here. I can go back and just change it easily, right? I want to change it to, and you can see how easy it is to edit this data Whereas if you do the command to change it to 2, you have to say, update, right? Update table grades, and then set grade ID equal to 2, where now what? You can't say grade is 1. You just say where maybe grade point is 85, and that grade is B or something, right? To match that, to change that value. But here, you can visually just go in it like an Excel sheet. Very easy. Okay, so to delete indexes, you could just go back to the command here and drop index. The drop index, if I remember, it's a little bit. You have to mention the table name plus the index name. Okay, so you can go like drop index. The table name is grades, and then dot followed by the index name, ix grades, and then grade ID. And I think that should drop the index. Okay, so that's removed. And if you refresh your table here, just right click and refresh, or refresh it here, and you look at the index is now gone. Okay. Then you check the disk usage. If you refresh, the index should be deleted, and that 24 should go back to 0, because there are no index. Well, actually, it's 8. Well, we have data on there, so I think the default would be set to 8. So now I want to go back here and just make sure that my grade ID is 1 and 2. They're not duplicate. Okay. If it's not, you can change to 1, 2, or something that's not duplicate. I'm going to create an index again, but this time I'm going to make it unique. So if you go back to the query, and we're just going to modify this here. And let me just copy this. Actually, we'll put down here. So I have both of them. And I'll make it unique. So create unique index. That's just fine. You just say I have the same one, but it's okay. And I'm going to highlight this. Execute that. Okay. The reason why I changed this to 2 here, because if you have a duplicate numbers or data, then when you try to create this unique index, it will fail. You make it unique, but you have some duplicate data in this, so it will expect you to change that to a unique number before you can actually do it. Okay. So now we have an index created in here. If you refresh it, you'll see it's back. But now if you look at it, it says unique. It's non-clustered. Is unique. Again, the word clustered here, and non-clustered just tells you that your physical table structure looks like what I showed you earlier, what I showed you here. Looks in that particular order. This is the physical layout of your table, right? So if I put 10 here and 75 as C here, I put 3 and then 80 and a B here, for example. That is the physical layout of your table. It's not sorted, right? It's not sorted because it's not a cluster index. If it's a cluster index, then usually the column, the grade 1 here, will be sorted. If it's a primary key, right? They'll be sorted based on the physical table. If it's not, it was sorted if it's a cluster index. But anyway, now that's your physical table, physical structure, and then the cluster index, because this is a non-cluster, so it will grab that column here, the grade I column, create a copy of that into its own index. It's like a separate column and a separate table itself, and store the same number 1, 2, 10, and 3 in that column, but then it's sorted because it's an index. Okay, it's sorted by ascending order by default. When we create this this index here on the column grade, we say ASC here for sorted, right? So now if I try to enter another record here with the ID of 1, and if it's true, if it's unique, even though that's not the primary key, because I forced that column to be indexed, and then if I try to duplicate that row, the record, it should fail. Okay, as you can see, it failed. It says, cannot enter duplicate key row in the object grade with index of grades here. Okay, and you may wonder why. Because the table itself, it's not even, that's not the primary key. We didn't set that to be unique at all, right? So what you see here is actually index, because the index is dependent on the table. So every time we add a data, it needs to pass everything over to the index as well. That's why it says, oh, the index is, you're violating the index itself. So therefore, it cannot enter the data into the table because of that. Okay? So the index is not that column. It's a separate column itself. But it's duplicate. Okay, I hope you see that. Okay, so that's why you cannot enter that into the table for that purpose. So in a sense, it also functions just like a unique column, even though your actual column is not unique. Okay, so it's managed in this case by the index, or constrained by the index. So if you put 11, then that should be fine. Okay, why don't we take a break first? We'll come back and then we'll do I'll do a little bit more on the performance part, so you can see how things are calculated done on the back side of it. So maybe we'll see how the index will get used or not at all. We'll see. Okay, so I'll see you back in about 10 minutes.